So it's time. Let's get started. So I'll pass you the mic again.
Thank you. Good morning, everyone. Thank you for coming. This is Ryotaro speaking. And yeah, I can see my field work over there. Hey, coming. Sorry. Yeah, and this is not my first time to give a presentation in this room because I graduated this school 3 years ago. And I had been the student for 7 years. But this is my first time to give a presentation in English. So, okay, let's start it. Okay, okay. Let me introduce myself. Yeah, I was a student, a master student, and studied about just-in-time compiler at that time. But I'm now one of working adults since this April in Japanese, shinsotsu. And yeah, surprisingly, I was a salesperson, telephone caller, yeah, during new graduate training. So it's been a long time to leave from programming, a long time. So yeah, sorry to say, I almost forgot about PyPy. So it's really tough to make this presentation for me in this time. And yeah, please buy Copolida. Okay, and this is a disclaimer of this presentation. Yeah, as you may know, my English is extremely poor, and my presentation skill is extremely low. So please feel free to ask any question anytime. So if you couldn't understand what I say, you can stop my presentation and ask me anything, anytime. And of course, you can leave or re-enter here anytime, whenever you want. And of course, I'm Japanese, I can explain in Japanese and English. Okay. So today's topics. First is introduction regarding PyPy, and second is regarding just-in-time compiler. And third is what is unique features of PyPy just-in-time compiler. By the way, could you sorry? Could you raise your hand if you are non-Japanese? Oh, around 10? Okay, thank you. Sorry, my poor English. Okay. Okay, the first is what is PyPy? Okay, again, please raise your hand if you know briefly about PyPy. What PyPy is, you know. Oh, a lot of people. Okay, 80% was more over. Okay, maybe this session is not so useful for you, I think, because this is a brief introduction of PyPy. Okay. Okay, as you may know, PyPy is regarded as a faster Python implementation or a framework used to develop a language implementation. Yeah, actually these both two are definitely correct. And the first one is the instance of the second one. The second one is framework used to develop this. So first Python implementation is, how to say, the production of the framework. So PyPy is originally framework. But yeah, a lot of people tend to know PyPy is first Python implementation, I think. Okay, then let's focus to the PyPy's basic goal. Okay, the problem which PyPy project team think is that creating interpreter, in other words, virtual machine, requires a lot of work. Yeah, currently, as you may know, Mr. Guido writes his original Python interpreter by C for performance. Yeah, but as you may know, C or C++ is one of the low-level languages. So it costs too much to develop some virtual machines. And it requires language-based programming. It means, for example, if I develop a Lua interpreter, the code cannot be reused, almost cannot be reused to other implementation. And PyPy's goal is to be able to create interpreter easily by using high-level language like Python, and without giving up performance. Okay. And this figure shows the principle what PyPy do. PyPy is a toolkit to translate interpreter written in Python to other backends such as C, CLI, and Java, and so forth. The first implemented data, in other words, the developer who creates the interpreter creates his or her interpreter code in IronPython, and then developer uses PyPy to translate this code written in IronPython, and then PyPy translates the code into C, Java, and CLI, a lot of backends. So this is what PyPy does for a developer as framework. And implement. Sorry. Okay, sorry. This one is duplicated, sorry. Yeah, okay. Then what is IronPython? Yeah, IronPython is abbreviation of restricted subset of Python. The restriction are shown this here. For example, only single inheritance is allowed, and for loop only supports built-in type, and generator is actually supported, but exact scope is really very limited. And dynamic dispatch to class is not supported because these four features are too dynamic to translate other backends. Yeah, and these are required to static analysis for translating other backends. And the most worth saying here is that IronPython is being a subset. It can be executed by CPython also. Okay, then how to use PyPy as framework? So you need to download a source code edition of PyPy from pypy.org, and please make sure that you cannot use framework as a Python implementation by PyPy. So you need to download source code edition here, or I recommend you to use Mercurial version to study. And yeah, toolchain is not contained in binary distribution, so please make it sure. Then first you have to do is that write interpreter code in IronPython, something like that. So as you can see, this is really similar or same to original Python code. So needless to say, it can be executed by Python. And use translator here, like here, and most of all PyPy toolchain is implemented by Python. So this translator will be executed by CPython itself. Of course, you can use PyPy interpreter to translate your target source code. Okay. And then translate will be started. And this translation requires a lot of time and a lot of memory to execute. So, how to say? And if the memory in your machine is not enough, this costs too much. I mean, a lot of time will be required. So be careful. Okay. And then after the translation completed, it's ready to use, like this one. So the result of code can be executed by how to say, natively. If you execute translator without any options. So yeah, as I mentioned here, execute a binary which has suffix C, like this. So if I translate test.py, then test-c will be created. And this is executable binary file. And it is much more efficient than original Python code. Okay. Next is that basic flow, what PyPy did for given IronPython code. Yeah, as you can see, things are very similar to a compiler, but it does a lot of extra work, as you can see here. So first, a programmer execute a PyPy translator and input IronPython program, and then CPython interpreter, how to say, with the PyPy program itself, and then translate the given Python program to function objects. I mean, these objects are what we call intermediate representation. And then flow graphing and type inference will be executed here. And then after that, the representation will be translated to forest of typed flow graphs. And then transformation is executed to each. And then wanted code to backends will be produced. And it also can be done like adding garbage collector and adding just-in-time compiler automatically. So it's worth saying about PyPy. Okay, let's summarize what PyPy is. PyPy is a framework to implement virtual machine by high-level languages, and a tool which enables translate Python to efficient executable one. So for example, to be able to executing natively, or of course you can specify other option to product other backends such as CLI and Java VM and so forth. And just-in-time compiler and garbage collector can be automatically implemented to do that, to be able to executing natively and make it much more efficiently. Then, what is just-in-time compiler? Okay, again, sorry. Please raise your hand if you have any understanding about JIT compiler. Sorry to say, actually, this presentation is not so useful. Okay, but I succeed the. Sorry. Okay, actually, JIT compiler is abbreviation of just-in-time compiler. Yeah, just-in-time compiler is a compiler which is implemented to virtual machine. Yeah, this figure shows the role of virtual machine, which has a just-in-time compiler here. Once the script is given to VM, VM will interpret the script and then execute some instruction to physical machine. Yeah, once the script is executed frequently, then one of the how to say the partial code will be compiled, and then the code will be executed natively and executed efficiently. So in this architecture, VM is in charge of understanding script and instructing to machine, and compiling script in runtime simultaneously. And the compiler compiles partial code of given script during runtime to make it faster, efficiently. Okay. Then what is just-in-time compiler? Is that compiler which compiles executing script anytime or any parts to speed up later execution speed. This is a comparison between difference between the typical compiler and the just-in-time compiler. Compile will be done during compile phase in typical compiler, such as GCC or so forth. But in just-in-time compiler, the compile will be done during runtime. And time required to compile it's allowed to take a lot of time for a typical compiler. Yeah, a lot of time is acceptable. But just-in-time compiler compiles the given script code during runtime. So if just-in-time compiler uses a lot of time to compile during runtime, then the time required to compile will be latency directly. So how to say, the allowed time to use compilation is very limited. And a target in typical compiler, the target is typically word code. So if I compile code written in C, then compiler will compile all of the code, all of the C code. But just-in-time compiler will compile typically partial code of given code. Okay, next. Then, as I mentioned here, typically partial code will be compiled by JIT compiler. But what does partial compilation? Yeah, as I mentioned before, just-in-time compiler cannot use a lot of time, so it cannot compile overall code. Yeah, it is in general case. Some of just-in-time compiler compiles a whole given script code. Yeah, but I explain about the general case. Okay. So, yeah, it cannot compile overall code. So, compile frequently executed parts only is partial compilation. Okay. This slide shows a way of doing partial compilation. Yeah, there are two types, two ways to doing partial compilation. The one is a very basic and not so general way to do that. It's function-based compilation. Yeah, it means that the minimum compilation unit is function itself. Its merit is easy to detect and easy to implement, needless to say. But as you can see, demerit is that a minimum compilation unit is up to implementer of functions. So if I write some script, and the script contains some function which has large size, then the minimum compilation unit will be increased, be much more bigger. Then compilation speed will be increased. Sorry, compilation amount will be increased, and then it decreases the speed during runtime. And on the other hand, trace-based is a much hotter one. And PyPy uses this trace-based compilation. And this trace-based is that minimum compilation unit is trace. The trace means sequence of running code. And I will explain it later. And the merit of this is that it can minimize compilation unit. Yeah, it is much efficient than function-based. And the demerit is that it is very difficult to implement still, and this way is still under research. Okay, and I will discuss this trace-based later from this slide. Okay, then in trace-based just-in-time compiler, how to detect frequently executed part? To detect frequently executed paths, just-in-time compiler prepares the counter to count how many times the loop is executed to each loop. Then, if the counter crosses a threshold, then the loop is regarded as a hot loop. Hot loop means this loop is frequently executed path. So hot is the keyword for just-in-time compiler. So after this just-in-time compiler detects the hot part, the involved code will be compiled, and then it will be executed much efficient by executing natively. Okay, the next is how will trace will be extracted. Okay, please assume this loop is usually executed, and x is usually 3. Yeah, then just-in-time compiler counts how many times the loop is executed here, and this flow is detected as a hot part. Then a compiler recalls a trace, in other words, a sequence of instruction like this. And yeah, this conditional branch will be translated to guard instruction. And the flow diagram will be like this. Then this is one trace in result of tracing this loop. And what is guard? As I mentioned here. Yeah, guard is one of the conditional branch instruction to switch interpreter execution or native execution. If God is true, it continues to execute natively. And if God is false, it switches to execute by interpreter. So this guard is used to assure not to execute part which isn't compiled during it is executed natively. Okay, by the way, do you think it is able to compile a Python like this? Yeah, as you can see, no, it isn't. Yeah, for example, this function f, in this function f, if the x is given as integer, the resulting value will be integer. And if the x is string, the result value will be string. And furthermore, if x is sequence like list, then the resulting value will be the list. So Python is being a dynamic typed language. Various type of machine code is required to each operation. So we cannot determine which type is required during how to say if I want to compile a Python code as compilable languages. So it cannot be compiled because it is one of the dynamic typed languages. And so, but what about just-in-time compiler? In just-in-time compiler, it uses guard, as I mentioned before, to compile each types. In other words, compile with versioning. For example, assume fx is used by passing integer parameter frequently. Then, just-in-time compiler adds guard here automatically to assure the type of x, like this. So once fx is executed and guard, which asks is x int, and then it will it assures the compilation path is this path. So using a guard to execute to compile during during runtime. So this is one of the privileges for just-in-time compiler. So if it isn't just-in-time compiler but typical compiler, this technique cannot be used. So dynamic languages can be compiled only if it is compiled by a just-in-time compiler. And of course, it can support compiling multiple types. For example, the fx frequently executed by passing integer parameter, and on the other hand, not only integer but also string is given frequently. In this case, just-in-time compiler can add another guard here, and then another version of compiled machine code will be produced and can be executed here. So in result, fx can be executed natively if x is int or x is string, something like this. Okay, this summarize of what is just-in-time compiler. Yeah, just-in-time compiler is a compiler used during runtime to compile partial code. and to make it able to be executed efficiently. And there are two ways to partial computation. First is function-based, and it is already obsolete. And the second one is trace-based. This is difficult to implement, but very efficient. And in trace-based, God does important role, such as assure to run in native correctly and enable partial Python code to be compiled. Okay, what about just-in-time in PyPy? PyPy says that once you implement VM in IronPython, PyPy implements just-in-time compiler for it automatically. But how? Does it generate just-in-time compiler? Actually not. This is a strategy to add just-in-time compiler to target virtual machine. Yeah, at first, implementing just-in-time compiler is heavy tasks, even for professional like PyPy team. So PyPy made only one just-in-time compiler for IronPython, and user writes the interpreter by IronPython to use PyPy. And PyPy's just-in-time compiler works for the interpreter. For interpreter means the interpreter written in IronPython. Yeah, it's equivalent to supporting just-in-time compiler to target interpreter, they said. This is. This is what we call a sandwich architecture used in PyPy. So this is PyPy just-in-time compiler, and this compiles and trace and acquire trace the interpreter written in IronPython. And this IronPython program will interpret target program. So it's what we call sandwich. And yeah, PyPy uses a unique way to record trace. It's what we call meta tracing. In typical tracing, just-in-time compiler records execution paths for implemented language. For example, I implement Python, then typical just-in-time compiler traces the sequence of Python itself. So I mean, in typical tracing, one just-in-time compiler for one language implementation. So one language needs the dedicated, only dedicated for the implementation. On the other hand, PyPy records execution paths for language, which implements target language. I mean that PyPy records the execution path of this, not this one. So one just-in-time compiler can compile for any language implementation. And what about speed? Yeah, this meta just-in-time compiler produces roughly 2 times faster compared to CPython. And yeah, why is it able to make it faster? Is that that's because data operation will be targeted for just-in-time compiler. In general case, such data operation out of scope for just-in-time compiler because it is really difficult to implement. And the GERD increases opportunity for constant folding. And it's very efficient to apply constant folding to data operation. So these two are critical for increasing the performance. Okay, this is a summary of what PyPy's JIT is. PyPy's compiler doesn't generate just-in-time compiler, but it traces virtual machine written in IronPython, not trace the target interpreter. And what meta tracing is that it recalls virtual machine instruction, not program's instruction. So it's what we call meta level. And it is realized by introducing sandwich architecture. And in meta tracing, it achieves about 2 times speed up. But it isn't over yet. PyPy introduced dramatic technology to speed up dramatically. One of the unique technology originated by PyPy project is that hinting mechanism. Hinting mechanism is that the programmer can give annotation for just-in-time compiler in their interpreter written in IronPython here. Like characteristic of a method implemented in here, like this method won't change its member variable or characteristic of variable, like this variable is used for program counter, something like that. And I will introduce some of hints used in PyPy. Okay, the hint one is green variable and red variable. Green variable is classified as program counter, and the variable which is related to program counter, such as list, which contains bytecodes. And the red variable is other variables. Yeah, to classify the green variable and the red variable, PyPy's just-in-time compiler can know that currently virtual machine is running loop by looking this green variable. So it is very efficient to know which to start recording the trace. And a hint can give like that. So you can write such a code in your virtual machine code like that to let the PyPy just-in-time compiler to know which is greens and which is reds. And hint 2 is that indicating a just-in-time match point like that. This hint is placed where the interpreter main loop is begin. It tells this loop is the beginning of main loop to JIT compiler. Then JIT compiler can easily detect efficient path to compile. And the third hint is trace elidable. Please look at the program. And this program initiates the member variable x and y by a constructor. And then in function f, it varies its self y variable by this instruction. But this x variable cannot be changed after constructor is executed. So, yeah, this self x won't be changed after initial set. So it seems that self.x can be constant float. But as you may know, Python doesn't have private function. So if you can know, or if you are planning to this this self x is constant, then you can tell about that to just-in-time compiler by adding annotation elidable. This is a hint for this method can be constant float. And then let's summarize of hintings. These are three hintings, as I explained. One is that green variables and red variables. It says which is program counter. And second is just-in-time match point. It says where is main loop. And last is trace eligible. It informs just-in-time compiler that the method can be constant fault. And as you can see, these hints are very easy to implement. And all of them requires almost one line, only one line. And this is a result of applying hints. This is the time required to execute without hinting. And this is a result with giving hints. Yeah, as you can see, in result, it is 5 through 20 times faster than C Python. Yeah, it's dramatically, I think. Okay, next is that how can you utilize PyPy? If you use programming language which requires VM to execute in your project, then you can, how to say, to introduce a virtual machine made by PyPy to make it much efficient. Yeah, for a web programmer, recently, PyPy version of PHP is under development. You can find the page by search it in Google, PyPy and PHP. And it produced a very good result. And the project name is Hippie. It produces 7 through 15.4 times speed up compared to Zend, and 1.3 through 5.3 times speed up compared to Hip-Hop, which has a just-in-time compiler. It's still under development, but it is possible that your web application will be much efficient. Okay, this is conclusion. PyPy is framework for implementing VM in dynamic language easily without giving up performance. And PyPy uses just-in-time compiler, which uses meta tracing hint mechanism to achieve great performance. Even programmers don't have to implement just-in-time compiler. And it might be real that all existing interpreter can improve their performance by implemented by PyPy, such as PHP, as I described. Okay, so of course you can ask me now, but the time is almost up, and I will answer your question in these social sites, such as Facebook and Twitter. My account can be easily found through PyCon-JP 2020 page. Okay, that's it. Thank you for listening my ugly presentation. Thank you so much. That's it.
So you guys have any questions?
PyPy のソースコードを読むときにどういう順番で読み進めていったらPyPy 理解しやすいかっていうアドバイスとかいただけませんか？
はい、ありがとうございます。Okay, his question is that how can I study about PyPy by reading the PyPy source code, and which should I start to reading which source code, and this answer is very difficult, but yeah, it's really a good question. Yeah, I recommend you to read from how to say sorry, I forgot the name, but the source code. Okay, I recommend you to read translate.py. Yeah, it is also mentioned in my slide. So I will upload this slide later, and you can see it. Yeah, translate.py is what we call the top level for that. So you can see how to say. You can read the source code from top down. How to say, to the method. Then you can catch the how to say, the overall information through that. But please make sure it is very difficult to read them all. And yeah, and I and Ike-san next to you succeed translation from English to Japanese for documentation. So you can read this, please, after translation. Okay, thank you.
Anybody? Nobody has a question? The runtime is only one aspect of an application. How does it look like with the startup time?
Startup time?
The startup time of an using PyPy. How does it compare to a regular Python interpreter or C Python code?
Yeah, it's a very good question. Thank you. Yeah, as you can see, the just-in-time compiler is extra program compared to C Python, and so it requires start time at few second how to say, few second order. And so the start time is actually take some time, but yeah, as you can see the result of this one. Yeah, it seems that this benchmark is a result which deduct the initial time required to start up. So as you say, if it includes startup time, it will be much slower than C Python. But if you use a program which requires minutes or hour requiring program, then it is worth using PyPy. Thank you.
すみません。そのPyPyを使うときに、例えばJava 実装の JSON でしたっけとかだったら、C 実装のそういったモジュールが使えないとかってそういった問題があると思うんですけども、PyPy の場合はそういった要は問題とかってないんでしょうか。どう
なんだろう。Yeah, the question is that sorry, in JSON it cannot be used module which is written in C. And how about PyPy? Is this your question? Yes. Actually, I don't have much understanding regarding about PyPy because I studied about just-in-time compiler. But how to say? Yeah, actually, I don't know about Java virtual machine, but PyPy introduced some interface to implement module which is written in C, like C types. But I guess in Java it doesn't have enough interface to implement other module. I think that's it. Sorry.
Who else has a question? Oh, I have a question for you.
Okay, please.
How about memory usage of the Py after using JIT compiler or just normal some C Python?
So memory usage. Yeah, it really depends on the what kind of program we've executed. It really depends on the program itself. But yeah, it's not so compared to CPython. But make sure it requires a lot of memory when you translate Python to other backends. But in executing part, I think it's not so comparable. Okay, please.
This is the first time I heard about the PyPy. For the first, if I have suppose I have a code, and I run with PyPy for the first time. If I have a code and compile with the PyPy for the first time, if I run the same code the second time, would the compile code like if we run the code already and then we run the code again, would the compile code still there, or the PyPy have to recompile the code again?
Yes. Yeah, currently, PyPy requires recompile over all of the given compiled code. This is a good question. Yeah, PyPy of course can reuse the code, but it has a lot of problem because, as I mentioned before, the God place will be changed by given parameter from user. So it will be a large problem that how to preserve the status of God. So currently, I think PyPy doesn't preserve the completion code, but it requires recompile when you re-execute the PyPy, I think. Thank you.
Okay, so time is coming. This will be a last question. No questions? Okay, let's wrap it up. Thank you for your interesting speech.
Thank you so much.